Hey guys, I'm audible. Guys, I'm audible.
Yes, Dinesh.
Hello. Guys, I'm not able to hear you. Will you guys able to hear me?
Yeah, we can hear you, Dinesh.
No, I'm not able to hear you. 1 minute. What happened to my audio connection? 1 minute. Let me check it. Can you quickly confirm? Am I audible now? Or still no?
I'm
No.
able to hear you, Dinesh. Can you hear us? Can you hear me?
No. I am audible, but I am not able to hear you guys.
Yeah, can you hear me, Dinesh?
Only 1 minute, guys. Let me change the. Now, can you talk?
Yeah, this is Sam. Hello, hello.
Okay. Hello.
Yeah, Dinesh, can you hear me?
No. Guys, is that okay? Can we proceed? Because I'm not able to hear you. If you have any question, will you put it in the chat box? Are you okay? Is that okay? Or do you want me to restart my machine? Can you tell me in the chat box? Do you want me to restart my machine or you tell me any question in the chat box? Okay. Okay. Let's discuss. So we just started with our DevOps, but today I'm going to teach one of the tool, a leading tool in the market, which is nothing but Git. Today my topic is Git, right? We are going to utilize the Git. So before understanding the Git, I'm going to tell you what is SCM. SCM is nothing but source code manager or source code management. Source code manager or source code management. So what is SCM? What is source code management or what is source code manager? Okay. Remember guys, can you guys tell me what is source code management or source code control or whatever it might be, source code manager? What is that? What do you understand from this term? What do you guys understand from this term? Source code management or source code control? Guys, remember, in a company, if there is a developer, the developer basically they will write the code, right? In Java or Python or JavaScript, whatever it might be. Whatever the code which is written by your developer, that code basically we can call it as source code. The developer, they are writing the piece of code, right? That piece of code, we simply call it as source code. Now, what the developer role will do, whenever they are writing the code, whenever they write any piece of code, this piece of code maybe they will have it in local machine, right? They will have it in local machine. Now, in order to save this code in some remote machine or maybe in some cloud or any repository, any storage place, that is nothing but source code management. So source code management, where you can find the developer source code, whatever the code which is written by the developer, that complete code, you can find it in somewhere which is called as your source code manager or source code. Yes, it's a code repository, correct? It is a code repository where you can see the complete code. That is nothing but source code management. When I say management, what is management? Management means maintaining the code base. Management is nothing but here the developer, they will maintain their code. They will maintain or they will store their code. Why they are storing? Why they are storing? Because that code may be used by other developer also. Maybe that code is seen by other tester also or any product manager. Everyone can able to see that particular code. So we need some centralized place, right? That's the reason we can call it a source code management. The code which is written by the developer, that code will be managed in the centralized place. That's nothing but your source code manager or source code management. Git is one of the source code management tool. Like that in the market, we have a different tool, guys. Like we have a SPN also. This is also one of the tool to maintain your code, to store your code. So Git is one of the tools to store your code, to maintain your code. And remember, your Git, right? It is not only a source code management tool, it is also called as version control system. It is also called as version control system. It is not only a source code manager, it is also called as version control system. Simply, if someone is asking what is source code management, the code that is written by the developer, they will manage or they will maintain in some code repository or some a centralized server. That's nothing but your source code management manager. An example, Git is a source code manager. Are you clear with this? What is source code management? Can you quickly confirm what is source code management? Everyone clear?
Yes, Dinesh.
I'm expecting your answer, guys. What is source code management? Is that okay? Everyone clear with this? Okay. Now, what is version control? What is meant by version control? See, in real time, you definitely find the word called version, right? You find the version called version. What is version? If you ask me, whenever any, say for an example, there is a software. That particular software has some feature. Say that has two features. Consider we have a WhatsApp. WhatsApp has one feature, which is called a chat feature. And it is released to the market, maybe to the production environment, to the customer. The version, maybe we can call it as 1.0. And now WhatsApp, there is a major, consider like there is a bug in the chat. Some people, they are unable to send the message. There is a buggy code in it. There is some problem, a small feature issue in the chat. Now what will happen? There will be a bug fixes, right? There will be bug fixes on this chat. Now what the developer will do? The developer, they will release that particular product into the another version, right? Maybe consider it is 1.1. 1.1. Now we have a WhatsApp and there is a bug fixes have already happened. Now there is a new feature is coming to the market. Say WhatsApp is planning to allow audio feature also. It means that everyone can able to call with the help of a WhatsApp. Now this people, they will release, right, this particular product in the form of 1.2 version. Then what I'm saying, if there is a software, it will have a multiple version. Sometimes they will do the enhancement. Sometimes they will do the bug fixes. Sometimes they will remove some features also. Maybe if the customer is not happy with the particular feature, it is not giving a profit, then definitely the customer or the client, they will remove the particular feature, right? So then we will get the new versions. These versions and all, generally a years back or 5 years or 10 years back, the developer, he has to manage all this version manually. He has to manage all this version manually. Your company, anytime they will ask you the version, you are the person, you have a local machine, you have a laptop where you have to handle all this version. Is it easy to handle all the version? Every week, if you have a release, can I able to handle all the version? In your release itself, we will do the major or multiple changes also. Can I able to maintain all the version? It is not at all easy. Then how to manage? It is very difficult to manage the version. For that reason, if someone is coming, hey, I will manage all this version, you no need to worry. Whatever the changes that you are doing in your file or in your Java file, with all this version, I will have the track. I will have the track. I will record each and every changes over the time. We can go for, right? That's the version control system. So version control system, basically it will record, it will records or it will manage the changes pertaining to documents. Whatever the changes that you made it to the documents over the time, then we can go for this version control. So it, help us to track all the changes. It will track all the changes, track all the changes when multiple, even when multiple people working on same project. Multiple people work on same project. I will tell you one real-time example. I hope you all know Linux kernel. Linux kernel is one of the open source. It is one of the open source operating system. Linux kernel. So who implemented this Linux kernel? The author called Linus Torvalds. Linus Torvalds, right? Linus Torvalds. So that guy introduced this Linux kernel. The same guy introduced this Git also. The same guy introduced Git also. Guys, Linux kernel is a open source, right? When I say open source, what is mean open source? Open source, it is means that a free of cost. It is not only means a free of cost. It is also means that anyone can able to do the contribution. See, Java is a open source. When I say open source means what? Anyone can able to contribute, because in your world, there are many intelligent people are there. So if they are having a good idea with respect to software, they can also contribute, right, towards the particular code. This Linux kernel is the open source platform. Now, there are many developers, they are trying to contribute this Linux kernel. But what is the problem? See, guys, in a real time, if you are working in a project, if one developer, they are making some changes, other developer will not know, right, what is working. It is very difficult to manage the project. In a real time, even in a company, there is a project, there is a poor developer, it is very, very difficult to maintain the version. It is very, very difficult to manage your project, because all the poor developers, they are working in different, maybe a module or same module. End of the day, you have to merge all this module. Will it easy? It is very difficult, right? Then, if you take an open source project, there are thousands of people, lakhs of people, they will work with the same project. Is it easy to maintain all the version? End of the day, will it be able to fix or merge all the code changes to the single system? No, it is very difficult. It is very difficult because it is a one software, right? All the code should be merged, but it is very difficult. It is very, very difficult. That's the reason this Linus Torvalds saw the pain of this open source software. That's the reason he introduced a tool called Git. A Git is the version control system. It means that whatever the changes that you are doing, all these changes automatically will be tracked by your Git. You just need to write some command. That's it. Whatever the changes that you are making, you can able to have it. At what time? Who made these changes on this particular file? When these changes happened? How the changes will be happened? What is the previous code? What is the current code? Every track on the same project, every track, we can have it with the help of your version control system. See, suppose take one notepad. Now I'm writing something here and I'm saving this particular file. After saving this file, I'm going to add few more files and I'm clicking on save. Will I able to go for previous version? Because this is the first version, right? This is the first version. And this is my second version. And can I able to go for previous version? Notepad, it's very difficult. It's very difficult. Yeah, you have to, maybe if you have some drive, yeah, you can have all the version. But again, can I able to share this code to other developer? Yeah, through the pen drive or through the Google Drive, I have to share it. But everything I need to do it, right? It is very difficult to maintain. So that's the reason we are using this tool, Git. Git will have all the version. Git will save your code. Maybe let me give you another example. Imagine, say suppose a developer, there is a developer A. He creates some software. Say consider he creates a software. He creates a software. And say suppose he is the company, he is the consider is the company head also, he is the developer, he created one software. Is a basic software he has created. Now consider this company is a growing company. As the company grows, what I need to do? I need to hire more people, right, for that particular project in order to enhance the feature, right? What this developer A is doing, developer A is the company head, he is the CEO of the company. He created one software. Now the company is running, but the company is growing. For that reason, he is going to hire more developer now. He is going to hire more developer. Say consider there are 2 or 3 developer he hired. 2 or 3 developer hired. Now what developer A is going to do? Developer A is going to, whatever the code he has written, right? He has written some source code with help of a Java or Python. He is going to share this particular code to other developers because they are going to work on the particular project, right? All are in same project. All are working in same project. Now what developer A is doing? A developer A is sharing this particular source code to the other developer. Now what developer B will do? Developer B, what he will do? Say we already have a source code. We already have a source code. Say this source code considered as a 1.0. Source code version is 1.0. Now he is going to add some more features to it. He is going to add some more features to it. And now this version, maybe we can call it as 1.2 now. This is going to submit to developer A. He is going to submit this particular piece of code to developer A. Now what developer A is doing? A developer A is reviewing this particular code, is verifying these changes, and all looks well. Simply, what he will do? He will replace, right? Already we have a 1.0. Now he is going to replace it to 1, no, sorry, which is 1.1. Yeah, replace it to 1.1. Already he has in local machine, he has 1.0. Now what developer A will do? Yeah, I got the new features. Everything is looking good. Now what I'm going to replace this 1.0 by 1.1. Right? Now only the problem starts, guys. What? Say, if there is another developer, consider developer C. Now developer C also did some changes. Say already is currently working with the 1.0 plus he has added some features. These features is submitted to developer A. Now what the developer A has to do? Developer A, again he should verify this feature and he has to take the code changes and manually integrate them with what? Manually integrate them with the version code 2, right? It means that already we have a 1.1. That should be replaced. That should be replaced to 1.2, right? Already has the code of 1.1. Now he is replacing to the 1.2. Similarly, when the developer C I have done, right? Developer C. Now suppose consider there is a bug in the developer C, guys. What will happen? After merging, after we have replaced, right? Later stages, in later, developer A got to know that in the production there is a bug. There is a production in the bug. What is the production bug? Say consider 1.2 is not working. 1.2 is not working. The customer, they are writing some review saying that customer 1.2 is not working. So what this developer has to do? Tell me. Developer A, what he has to do? He has to replace it. He has to go for the previous version, right? The one is, he has to go for previous version, 1.1 or 1.0. First of all, he should have the backup at least, or he has created another folder where he should have the another versions also. Suppose it is not available. If it is not available, manually, every files I need to delete and I have to configure once again. Is it easy task? Guys, in a single file, if you have 1,000 lines of code, that itself difficult, guys. But in a real time, in a real project, there are lakhs of code which is written by the developer. There are many modules. It is very, very complex kind of files. You can find it in the real time. Is it easy to maintain? Is it easy to go for the previous version? Or is it easy to do the integration manually by the developer here? What do you think? Will you able to understand? Yes or no? Will you able to understand what I'm saying? Guys, here, all these versions are manual. That's the painful problem. Every version manually we have to maintain. It is not at all easy task. And even if you think like we can sit together with a developer and we can do the collaboration, it is a time consuming, guys. It is a time consuming job. Whoever they were working with this previous, manual version, they know what is the pain on this. And it is very, very hectic task. It is very difficult to maintain the version manually, every version. That is not at all possible. And sometimes, if you fail to save the particular version at the particular time, then we cannot access, right? No easy access to the previous version. We don't have a control on the previous version. Sometimes we may fail, right? And if you even, you are thinking like I can keep the multiple version in my machine. What about the memory? When you keep multiple version in your local machine, everything is memory, right? So obviously it will occupy a lot of space. So these are the few problems related to your version control. So whenever you go with the version control, whenever if you are not using the version control, you have to manually configure each and every version in your local machine, and it will be a time consumption job. Along with it, it is very difficult to maintain all your versions. And whenever if you keep a multiple version in your local machine, and yes, of course, you will occupy a lot of space in your machine, then your system performance will be very poor. Are you clear with this? What is version control problem? Yes, no? Can you quickly confirm? Are you clear with the version control problems? Why, what happened? No one is responding. Or do you want me to repeat anywhere? Fine. So simply, if you want to understand what is version control, you remember we are maintaining the version. Simple. We are maintaining the version over the time. How we are maintaining? Let's see practically. That time we will get to know that. And remember, there are two types of version control system. There are two types of version control system. A version control system and source code management. This is the term. It is available long back. Don't think like this word introduced after Git only. No. Before Git only, we have this term, source code management and version control system. So there are two types of source code management system. One is centralized version control system. Centralized version control system. And another one is distributed version control system. Now, what is centralized? What is distributed? What is centralized? What is distributed? Very simple. Remember, suppose there is a developer. Developer A, and we have a developer B. There are two developer A and developer B. And consider he is working on some feature, guys. He is working on some feature, say feature number A or feature number F1. And developer B is working on another feature number 2. Both are working for the same project, but there are different features is worked by developer A and developer B. Now, after his job is done, right, developer A and developer B, they have completed their task. So maybe they have used their local laptop, right? They are using some local machine, a local laptop. They have written the code actually, F1 and F2. Now, centralized version control system, where we can see one centralized server actually. We can see one centralized server. Example, Example, SVN. SVN is one of the centralized server available in the market. When you use the centralized server, right, basically your developer A and developer B, what they will basically do, they will save their code in the centralized version control system. Developer A and developer 2, they are storing this particular code in the cloud or centralized server, which is called SVN. Now suppose this is 1.0. 1.0. Now 1.0 is available in what? In the centralized server. Now suppose developer A and developer B, developer A and developer B, developer A and developer B, they are currently working on 1.2. Only the current 1.1, the only current code available here, once they completed this particular task, right, again that will be merged onto the centralized server. It means that suppose if I am currently working on some feature, right, that feature only available in the local machine. All the previous versions, it will be maintained on centralized server. That's the reason it's called centralized version control system. Only the current copy, current feature available in your local machine, all your previous changes, all your previous versions and all, everything available on the centralized server. What is the drawback here? What is the problem here? Say suppose your server crashed, what will happen? Your server crashed, what will happen? Obviously, you know, you will lose all your previous versions and all, because every data is available in your server. When server crashed or when you are in a place where we don't have internet connectivity, what will happen? Then obviously, you know, you cannot be able to get the code into your local machine, right? Yes or no? You cannot get the code from the centralized server to your local machine when you don't have internet connectivity. It means that there is a POP. It means that single point of failure. Your server, if it fails, what will happen? You cannot get any previous code. Suppose if your local machine got failed, then obviously you cannot get the current code. It's a single point of failure. One failure, it will, you know, affect all the developer. Yes, old versions are gone. So that's the problem with respect to the version control system, centralized version control system, because all your versions is maintained on only one server, which is your centralized server, example SVN. SVN is nothing but subversion network, right? Are you clear with this? What is the problem with the centralized version control system? Yes, Abba. See, your centralized version control system looks like. Basically, you know, it's the developer A and developer B and developer C. Developer A is working on some copy or some code, which is called a working copy. Developer B also is working on copy called working copy. And developer C also writing some feature. Committing means record, saving, right? So whenever the developer A is completed his task, what basically will do? He will push this code to the main server. And developer B is completed his task, he will push the code to the centralized server, which is called a main server. And developer C is also doing the same, right? But when your server fails, what will happen? You will lose all the older version. Suppose if your local machine fails, what will happen? You cannot get the code from the remote. Maybe you can get the another laptop, but where is your local code? You will fail to, you will lose the current copy, right? That's the problem. If you go with a centralized version control system. Centralized version control system. So here we have a system A and system B. There is a centralized server. Are you clear with this? What is the problem with the centralized server? So words of Git was introduced as. Yes, correct. Yeah, man. Yep. Right. See, then next we have distributed version control system. What is distributed? Distributed. It means that your code is distributed. your source code can be distributed. Let me take, you can see this one. You can see this picture. Say suppose laptop 1 and laptop 2 and laptop 3. There are 3 developers. They are working right now. That's called as working copy. That's called as working copy. Now using the Git, you can able to create a repository. You can able to create a repository. What is repository? Consider it's a folder. As of now, repository is a kind of a folder, directory. Now what is happening here? When you create a repository, right? Whatever the changes that you are doing in the working copy, all this version will be maintained your local machine. When you create a repository, whatever the doing that you made it on this working copy, say suppose you made 100 changes and you got 100 versions. Now all these 100 version will be maintained by your Git locally. In the same way, once your job is completed, you can push the changes to the remote, to the main server. Suppose developer A, he has pushed some code to this remote server. Now the developer B or developer C, they can pull the code also. They can pull the code also. Now suppose developer C has pushed some code to the server and developer A can retrieve this code also, pull this code also. It means that you have a copy, you have a code in your local, also in the main server. Now tell me, when your main server crashed, your code is available in local machine. All this version is available in your local machine. Now you may have a question. Hey, what will happen if my server crashed and also laptop crashed? Hey, other developer, they also have the local code, right? You can get the code from the developer B, or you can get the code to developer C. This is called distributed. Distributed means your all versions will be available in the remote and available in your local machine, also in another developer working copy. So your code is distributed everywhere. This is called as distributed version control system. Example, Git. Git is the distributed version control system. Are you clear with this? What is distributed and what is centralized? Yes, if you don't understand, tell me, I will repeat. What is distributed? What is centralized? Right. So what is the advantage if you go with a centralized version control system? If you ask me, in some system, people, they will go for centralized version control system. Why? Maybe they will see like maybe a security reason. One system where if you have a code, right, maybe we can provide a more security mechanism towards that particular server. But if you go with a distributed, of course, you know, your code is distributed multiple places. Yes, there is a lack in security. But again, nowadays, guys, in every IT company, almost in all the IT company, the people, they are using the Git for source code management and version control, which is distributed version control system, which is like a Git. So if someone is asking what is the difference between distributed version control system and centralized version control system, in dedicated or centralized version control system, we need a dedicated internet connection for every operation, guys. Right? Suppose if you want to push the code to your remote, of course, you need a internet connectivity. And in your local, if you want to pull the code from remote to local, again, you need a proper internet connectivity. Because whatever the changes that you are doing local, end of the day, you are going to push the code to the main server. And when you want to pull the code from the main server, of course, you need internet connectivity. But what is happening in the distributed version control system? Everything you can work on locally. For that, you don't need of internet connectivity. Whenever you perform push and pull operation, that time only you need internet connectivity. Everything except when pulling and pushing can be done, right? Without internet connectivity, right? So that's the advantage in distributed version control system. And remember, every developer here in distributed version control system has a full version of history, right? In their local machine. Even if your distributed system or server crashed or your local machine crashed, you don't need to worry. I can get the code from another developer. But if you go with a centralized, this developer just have the working copy and no version history. They don't have a version history on their local drive. Only it is available in the server. Guys, whenever you push the code or whenever if you get the code from the server, right, it is very faster in distributed version control system. Why? Because everything we are going to do locally, right? Only for push and pull only I need internet connectivity. Apart from this, all this history we can keep it in the local itself. That time it is very faster. But if you go with the centralized, then of course we need a proper internet connectivity. It takes some time. So these are all the both have their own merits and demerits. Let's not talk about that one here. But you have to remember, Subversion is an example for centralized version control system, and Git is the example for distributed version control system. So you first remember what is the difference between centralized and distributed. Nowadays, almost none of the company they are using the centralized. Everyone is using the distributed. In that, one of the tool called Git. But we have a mini tool like Mercurial. Mercurial is one of the tool actually. Mercurial is an example for your distributed version control system. And we have a Perforce. Perforce also one of the distributed version control system, but most of the company they are using Git for your information. In centralized, can't be pulled from local. In centralized, can't be pulled from local. Another day, I'm not getting Samuel. Can you come again? In centralized, can't be pulled from local. It means that, what does this mean? I'm not getting. Like another in centralized can't be pulled from. No, what I mentioned, Samuel, only the current copy is available in the local machine. In case of centralized, all the previous version will be maintained only on the centralized server. Then suppose if the centralized server crashed and your local machine also gone, how you will get the code from another developer? Because another developer has only a working copy. They don't have a previous version. But if you go with the Git, in local also you can find the versions. In remote also you can find the versions. And every developer, they are also having the versions. Are you getting something? Do you want me to write some diagram or are you clear? Somewhere, let's see this picture. In centralized version control system, here we have a different developer, right? The developer, they have the working copy. They don't have a previous version. Where is the previous versions and all? It is available in the centralized server. Now, suppose Samuel is writing the code. Now, your code is completed, right? You have to push this code to the centralized server. Now you will work on another feature. Where is your previous feature? It is not available in your local machine. It is available in the server. But if you go with the distributed, suppose you are working on some piece of code and you will create your versions in local itself, I am saying. And this version will be maintained on the distributed server also. Now, where is your versions? It is available in your local and also it is available in your remote. Now, suppose if your remote gone, you can get it from local. If your local is gone, you can get it from remote. If both are gone, then you can get it from another developer. That is nothing but distributed. Yes, Jaya, there is no need to worry about your memory space. That will be taken care by your Git. Git will take care. Okay. Everyone clear with this two terminology? What is distributed and what is centralized? Okay, fine. And now I'm going to tell you some terminology, guys. Some terminology you have to remember with respect to Git. What are they? There are three terminology. Remember, one is working copy, and another one is staging area. Third one is commit area or commit. So this three terminology we have to use a lot. In Git, we need to use a lot, guys. This is three terminology: working directory, staging area, and then we have a commit. Now, what is working directory? Say suppose now you are going to work on some project. You are going to work on some project. Let me take one example. I will take my Eclipse. So Eclipse is one of the editor actually, where we can write the Java code. Generally, developer, they will develop their Java code with help of Eclipse. It is one of the tool actually to develop the Java code, to write the Java code. Like that in the market, we have a mini tool. See, in this particular tool, I have created a mini project. Let me take one project. I can take, this is one project. Say this is one project, right? Let me click on control. No need to worry about this code and all. Right here, they have written the many code, guys. When I open this one, see the developer, they have written the code. Generally, developer, they will write the code. Okay. Now, no need to worry about this one. Let me go to the location actually. I will go to this project location. Where is the project location? Yeah, this is the project location. Can you see April Java session 7 p.m. April Java session 7 p.m. Right? So this is the project location. Generally, this project, right, it is stored in my local machine. It is stored in local machine. Now this is called as working copy. The place where your project resides in your local machine, local disk. That's nothing but working copy. So this directory, it is also called as working directory. This project, maybe we can call it as working copy or working directory. Are you clear with this? What is working copy or what is working directory? What is working copy or working directory? Simply a folder where you have written the code, right, in your local machine. That's nothing but a working directory or working copy. Your code is available here. If you open this one, you can see, right, that particular code, data types and variable demo, data type and variable demo. This is called as working copy or working directory. Simple, where you have written the code. Right. Now, project resides, right? That basically we can call in local machine is called as working copy. Now, remember guys, now if someone is asking, hey, is that working copy is tracked by your Git? No, not at all. So far, you have written your code in your local machine. Git is unaware about this working copy and all. Now suppose if you want to track each and every changes on your local machine, on your local file that you are making, for that we need a support of your Git, right? For that reason, you need to install a Git actually in your local machine. When you use a command called git space init is one command is available. When you use this command, what will happen? What will happen? Now your Git will take the responsibility. It will start track your code. It will start track your changes. So git init, it simply means that it is going to initialize an empty repository. It is going to initialize some empty repository. If you are not clear, I will tell you. See, suppose I will open, I have one bash case. I have one git bash. Okay. So before understanding this working copy and staging area, better I can go to the Git official website. Let me go to the Git and press enter. So can you see here? This is the Git URL. And what they have mentioned, Git is a free and open source, and it is a distributed version control system designed to handle everything from small to very large project with the speed and efficiency. Git is easy to learn and has a tiny footprint with a lightning fast performance. It outclasses a source code management tools like Subversion, CVS, Perforce, and ClearCase with features like they are, dominating this particular different, other third-party people. So CVS, Perforce, and ClearCase, it is also a distributed version control system, but Subversion is the centralized version control system. Git is the distributed version control system. And what is the latest version? Which is 2.40.0, and it is for Mac is available. And now majority of your company, most of the top level companies like LinkedIn, Netflix, Eclipse, can you see Eclipse, Genome, PostgreSQL, all this company, Google, Microsoft, Twitter, all this company, they are using Git. They are using the Git for their version controls. Right? Now we need to download this Git and we need to configure in our local machine. But before that, is anyone connected with your laptop? Can you quickly confirm? Anyone connected with your laptop or everyone connected with the mobile? Okay, Sam will connected with the laptop. Sam will, let me make you as a host. You just, share your screen. Sam will, you are host now. Share your screen. Right, super. Open your new tab. Open new tab. Yes, just type git download. Press enter. And click on this. And Windows. Yeah, click on this. And wait. Your machine is 64-bit. You can go with, I think it will automatically install. But can you see above, there is a git. No, above. Top. Click here to download. Yeah, you can click on this. Yes, it is downloading. So everyone has to go for this git.scm.com/download, and based on your operating system, just to download, guys. Yeah, you can install. Just click on next. Click on next. And click on next. Go back. Go back. Can you click on this additional icon on the desktop? We can keep on the desktop. First one, checkbox. Yeah. Yes. Click on next. And click on next. Back. Go back. Yes. Click on next. 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 Yes, install. It will start installing your Git in your local machine. This is only going to act as a version control system. It is completed, right? Okay. Now in the start, can you, okay, this is the bash. Close it, that one. Close the summary, that one. In the start, can you type git? No, in the start. Yeah, correct. Can you type git? I'm sorry, you are correct. Type git. Now you can find the bash, right? Double click on this. No. Left hand side. Yeah, that's also fine. Fine. That is a git bash. Fine. Right? So this is a kind of a command prompt, guys. Simple command prompt. Git bash is also a kind of command prompt. Here we are going to write the multiple, commands. What this command is going to do? It is going to save your code into the centralized server. Sometime I need to pull the code from centralized server to local. That time, this is the one we are going to use. Let me stop it here. But tomorrow, what I'm expecting from you all, please download Git SCM like Samuel done. Tomorrow we will start the command and all. Are you clear, guys? Can you install
Yeah.
Git SCM tomorrow? Only installation I have done. Sir, you said it acts as a version control system here. Yes, it is only going to act as a version control system. See, Aman, there are different way in which we can interact with your Git. One is with the help of a GUI. For that also we have a mini tool. But most of the as a solution architect, as a DevOps engineer, you have to use the command, right? For that reason, we are going for Git bash. Git bash is a kind of a terminal. It is a kind of a command prompt. Using this command prompt, we are going to write some command. Thereby, you can able to maintain your version in remote as well as local. How? That will see practically. How we are going to perform? That will see practically. There are 2 or 3 sessions I'm going to take with respect to Git. Definitely you will understand that. Okay, yeah. We'll see tomorrow. Okay, guys. Thank you. Let's see tomorrow.